Hi, good afternoon, Professor. I am Venkatamacha, and I am going to talk about my music exploratory data analysis data science project. So, the in the music analysis system that I and Shivram have built, uh, I am analyzing a person's music streaming history and drawing conclusion as to how his mood is changing during different hours of the day or different months of the year, etc. We know music is a great social connector. It unites us across markets, ages, backgrounds, political leanings, and preferences, etc. Music players and other streaming apps have high demands as these apps can be used anytime, anywhere, and combined with daily activities, traveling, sports, etc. With the rapid development of mobile networks, digital media technologies, digital music has become mainstream consumer content sought by many young people. People often use music as a means of mood regulation, specifically to change add mood, increase energy level, reduce tension. Also, listening to the right kind of music at the right time, improve mental health. Thus, human emotions have a strong relationship with music. So, I'll be looking over my music streaming history to figure out what kind of music I like. This analysis help me get better knowledge of my music listening preferences and behaviors. I'm going to elaborate on the future use of the recommender app, which is a complete picture in the conclusion of this presentation. Thank you. Shivram will be continuing with the next section, where he is going to talk about data gathering, data cleaning, and pre-processing. Thank you, Professor.
Thank you, Teja. Good evening, Professor. Coming to this project, my contribution is in two phases in this project. One is data fetching and another one is data cleaning. I'm employing methods of data frames such as drop columns, removing duplicates, null check, and data formula check. So here is the first one, data fetching. I'm exploring my music streaming history and will infer my varied music taste with the help of the analysis. For this analysis, I'll be fetching my data from Spotify, which I'm using from last 2 years. I'll get the data from the Spotify. Once I receive the data from the Spotify, I'll extract that file, which is in the form of JSON. Here are the following format like follows.json, identify.json, inference.json, and so on, etc. After that, fetching information from the Spotify, which is the raw data, the Spotify mails to the user does not have the critical information such as the date, music, timestamp, and etc. To generate this information. This is the code that I will develop to generate the missing information. uh, I imported Spotify packages. All the code I have written is fetching data from the Spotify and converting data into two main objects. This is the code and generating two objects. Those are songs.csv and playlist.csv. After generating two data sets, the next is data cleaning. So I'm going to explain about data cleaning. Before starting out with data analysis, it is important to check the data and solve some issues in the data. So for that, I'm doing dropping columns. The columns that are not required, I'm just dropping them, such as name, ID, etc. So removing duplicates. Since I have listened to a single song multiple times, to avoid that, I'm removing duplicates. Coming to the next one, null check. Checking the empty cells and filling them is important. So there is no empty cells, that is there is no need for removal. And coming one is data format check. In this, we are checking the attributes matches with their data type. So value check. In this, we are checking if the content inside the cells are correct or not. So by finding the max and minimum numerical values, we can determine these values. So yep, yes, professor, and this is the summary of my work that I explained before. To summarize what I've done, I will generated two data sets. As I mentioned, one is songs.csv and playlist.csv. From these data sets, I'm removing columns which are not needed, and I'm removing duplicate data, and I'm performing null checks and removing null values also. And performing value check to check the values that are correct or not that present on our data. Thank you, Professor. That's my work. Teja will continue from next.
Thank you, Shivram. Yes, I'm going to continue on exploratory data analysis. I picked up few musical attributes from the data set that Shivram has generated, such as tempo, energy, danceability, loudness, balance, and I'm going to use these attributes and determine how my mood changes across the year or different hours of the day. So for that, I have been using various plotting from libraries such as CalPlot. So first I'm going to analyze my music streaming history. So I've been using for the past few years, and then I'll be visualizing the data by converting the time into proper format, and then I've plotted a graph that's similar to GitHub's graph plot in the GitHub landing page. So, what songs did I listen to most? So, this is the analysis of what songs I have listened to most, and I've been plotting them. And you can see here, I have listened. These are the few other artists that I've listened most frequently across the last few years. And then this is some plot diagram where it shows the names of the artists, and again a full-blown plot diagram to show which artist songs track numbers I have listened to the most. And to understand my mood throughout the year, so I have used some valence algorithms. I'm going to plot the valence on a chart, and then I'm going to match with the energy and dance values, and come to a conclusion. So here comes the feature analysis. So I'll be analyzing the features of my music list. I'm going to again drop few columns and generate a histogram plot. So this is going to plot against the musical attributes key and mode, and then I've generated a few heat maps matching across the various musical attributes. So from the heat maps, we can draw a huge correlation between loudness and energy, balance and danceability, and etc. Just to summarize, we can say that scatter plots are a great way to determine relationship between two variables. So I'll be plotting it for the variables which we found strong correlation, and scatter plot pivot table as different artists have different pictures, and key is a major factor in music. With the help of the pivot table, I can get the average key of songs that are sung or created by them. And from my music playlist analysis, here is few of the various plots I've drawn. This is um, a bar chart, some scatter plots, uh, and I'll be again analyzing the different songs I played throughout the year here. And yeah, to conclude, the visual analysis gave me a better understanding of my data, or the musical patterns the various mood I have experienced during various times of the day or parts of the year. So it gave me a better understanding of all such data. So that's the end of the work would we have done, and so the future work would be developing a mood-based music player that recommends songs depending on the mood of the user. So this becomes a great add-on to the current music player application that could become pre-installed on our phones. So they already have a music recommender system, but this system is going to be play music on based on the user's mood. So we can even incorporate other dimensions such as heart rate or body temperature uh, to even get better results. So it's going to be a very interesting future expansion. Yeah, I'm looking forward to work on it sometime. But yeah, that's the end of the project. Thank you for this opportunity. Thank you.
Thank you.